carbon reuse economy, we want to leave that carbon which is underground to stay there underground and utilize that carbon which is already overground, for instance from the forests and other biomass. But that is not enough. We also need other carbon sources like carbon dioxide from industrial emissions and even from the air, so that we can capture and convert that to all kinds of goods like fuels, chemicals, materials and food.
Most of the commercial CO2 that is used today worldwide is coming from fossil fuels, one way or another, basically natural gas. So the CO2 capture units are designed to use very clean gases.
Le biogaz deviendra probablement la source primaire de production de CO2, car nous avons dans le biogaz plus de 40% de CO2. C'est la façon la plus économique de produire du CO2.
L'intérêt du projet est d'utiliser le CO2 qui est un CO2 fatal, qui est perdu dans les gaz d'échappement et donc dans l'atmosphère, pour le combiner dans une culture de microalgues et fabriquer des chaînes protéinées qui vont servir dans l'alimentation du bétail en remplacement du soja.
The main thing that we're doing is treating carbon dioxide as a waste material that can be recycled in the same way as you would recycle a plastic. We start with a cellulosic material, so it can be something like a grass, agricultural waste, can be wood chip or partially composted materials. We then coat that with a nitrogenous material, which allows the carbon dioxide, which we draw from an exhaust stream, to be attached to the cellulose. We then stabilize the carbon dioxide on the surface of the cellulose, making it into a strong carbonate material. We then add a few extra materials that can be used as plant nutrients, pelletize it, and then it's ready to be used as a fertilizer.
The most innovative part of this project is the first, as we know, that will produce food industry quality CO2 using exhaust gases from a biomass boiler.
We are aiming for different kinds of processes and technologies where we convert then carbon dioxide and renewable electricity through hydrogen to fuels and chemicals and materials. We are currently demonstrating the process and hoping that can be commercialized in a few years.
Relativement au gaz d'échappement, nous avons en France une installation qui capture du CO2 d'un gaz d'échappement d'une centrale à charbon. Ce CO2, il a une concentration de 10%. On le concentre jusqu'à 50-60%. Alors on transforme du CO2 en un produit chimique.
Like 70% of the CO2 we are going to produce will go to the food industry, basically in the Spanish market. And like 30% of the CO2 will be sold to a neighbor greenhouse and will be used to increase the production of this greenhouse where they produce roses.
Un exploitant agricole nous a proposé de récupérer le CO2 qui est dans les gaz d'échappement de son cogénérateur pour cultiver des microalgues et avec ces microalgues en faire de la nutrition animale pour ses vaches. Lui, son objectif, c'est de se dispenser d'acheter du soja et donc d'avoir ses propres protéines qui sont fabriquées avec un accélérateur qui va être un concentreur de CO2.
By the end of 2021, we will have a fully integrated low-grade biomass facility where our input will be different kind of biomass that we are already using today, coming from agricultural activities, from forestry activities, and the outputs we're going to have are commercial CO2, heat, power, and organic fertilizer with no residue.
It's about making the best use of our resources, and we're able to significantly reduce the cost and carbon footprint of fertilizer simply by drawing most of the ingredients from within current waste sources. Because key to what we're doing is that our approach actually allows you to make money and doesn't require financial support from government in the long run. In its own right, this technology has the potential to either directly save or avoid the production of millions of tons of CO2. And perhaps more important than that, it can demonstrate at a very basic level the importance of carbon capture and utilisation as opposed to storage in reducing global greenhouse gases.
Cette solution, donc on l'a étudiée en termes de faisabilité. On espère pouvoir faire un démonstrateur en 2020 et pouvoir le proposer en commercialisation en 2021. Le prix économique est relativement faible. Ça permet de produire les protéines en dessous du prix du soja en termes de teneur en protéines.
Biomass to power facilities can be catalyzers for other activities where we are able to get value out of usually non-valuable outputs like CO2 and ashes.
Et comme ça, l'exploitant de l'ISDND valorise de deux côtés son gaz. D'un côté, il continue à produire de l'électricité. De l'autre côté, son CO2 est utilisé pour alimenter des serres.
Et donc, ceci nous permet une indépendance économique de nos territoires vis-à-vis de la fourniture de protéines, que ce soit pour l'alimentation animale ou l'alimentation humaine.
For carbon capture and utilization will be commercialized within few years, and we will see, for instance, significant volumes of electrofuels, so-called electrofuels, some fuels based on renewable electricity and carbon dioxide around 2030, and it would be kind of the significant way to mitigate the climate change.
So we can grab waste from essentially stuff that's produced by people in their homes, waste that's produced by big industry, combine that with carbon dioxide that we all know is a massive problem, and actually turn it into something that literally makes things grow.